Hello, in this video we are going to focus on a task called the continuous multicolored circle of squares. So I'm just going to run the program quickly and then we will walk through from start to finish how this project could possibly look. And the focus is going to be mostly on the junior division curriculum. So grade 6 where we start talking about efficient code that may or may not include conditional statements, nested events, but basically with the focus on efficiency. Grade 5 level curriculum definitely being able to target conditional statements, grade 4 curriculum targeting nested events. But mostly this task, you are going to hear me reference grade 6 being able to code with efficiency. Coding with the fewest number of steps possible to make the program run quick with the least amount of memory in the most efficient way possible. So you can see running this program, I do have a continuous multicolored circle of squares. Everything is going to initiate with one square. So let me just get out of this program right now, and what I will do is create a brand new page and we will walk through the steps. And again, some of you, if you are watching this video, you may or may not have a background using block coding concepts within the Scratch environment, and if you don't, that's okay. And if you do, this might be something that you find helpful. You might learn something new. But again, this is mostly targeted for people who are not already familiarized with the Scratch program. So right now I have a brand new Scratch page. This area that I'm hovering on right now is called my canvas. And the area that I'm moving to right here, this is what I am going to refer to as my stage. So I'm going to leave the Scratch cat as my sprite. So any character that I am coding in Scratch is called a sprite. And I'm going to start with a backdrop. In the lower right-hand corner, I choose a backdrop. For this particular activity, we are going to be focusing on the Cartesian plane, the coordinate grid with the X and Y axis. So even though Cartesian planes are not really discussed at the grade 6 level, it's still a good way to introduce and talk about XY coordinates, because everything that we are doing in the Scratch program, as far as locations and movements of sprites, are all based on the XY coordinates. So at this point, I have my sprite, the cat, located on a Cartesian plane. I'm going to be starting my program from the origin. So again, another mathematical concept that relates to the coordinate pairs of 0, 0 on the XY axis. And I'm going to start building my code because step number 1 in this program is going to be have your sprite draw a square starting from the origin. So for me to have this sprite right now start to draw a square, I need to be able to come over here to the left-hand side. I have a number of different colored circles that are all related to different types of blocks, motion, look, sound, events, and so on. We are going to be talking about a handful of these in this project. The very first one I'm going to start with is from the yellow events block. Everything in Scratch is based on click and drag, so I grab the green flag and I simply drag it over to my canvas area. I'll just magnify that a little bit to make it easier to view. The green flag is going to initiate the code. It's going to be my launch button. So once I'm finished coding, I can click the green flag and that will start my program. So when the green flag is clicked, if I'm teaching this in a classroom, one of the things that I talk to students about is program the sprite to always go where you want it to go so that you don't have to continuously drag the sprite somewhere else on the screen. So right now I want my sprite to start at 0, 0. No matter where else it is on the screen. The easiest way to do that is by going to the blue motion blocks. And there is a coordinate, there is a motion block right here based on the coordinate pair XY that says go to the XY value. And anywhere you drag the sprite on the screen, this XY value is automatically in the background calculated based on where you drag the sprite to. So if I want the sprite to automatically go to the coordinate pair of 0, 0, when I click the green flag, now when I click the green flag, this cat should automatically move to 0, 0. Just like that. The next thing I want to do, because I'm going to have the cat draw a square, is I need to decide which direction I am going to start my square. And this is something that if we talk about how to move in the shape of a square, some students really struggle with because they say, well, just move in the shape of a square. I need to tell this cat, do I want it to start moving to the right? Do I want it to move up? Do I want it to move to the left, or do I want it to move down? So I need to be able to set the direction that I want my sprite to start moving. there's a coding block under the blue motion blocks that says point and direction. So I'm going to grab this, and if you click the bubble where it says 90, it gives you a built-in compass, a directional compass that you can drag the arrow, and this will indicate the direction that your sprite will start moving in once you have it programmed. I want my sprite to start moving this way to the right, which is set at 90, so I'm just going to leave it at that value. So now when I click the green flag, my sprite will move to 0, 0, point in direction 90, and now I want the sprite to start moving in the shape of a square. So at this point, we would start talking to students about what are the properties of a square. And what we are ultimately looking for is to drag out the ideas that a square is a four-sided shape, of which all four sides are equal side lengths, and they have four 90-degree angles. They might say right angles, but it's very important to make that connection that it's a 90-degree angle. So to start building this, we are going to use the move block to be able to set our side lengths of our square. As you can see by looking at this coordinate grid, the Cartesian plane is the background. The distance from 0, 0 to this point right here says 100. So that is the x value of 100. But the other thing that this shows is that that would be equivalent to 100 steps. So to get the sprite to move from the center to this point right here where it says 100 is 100 steps. So I'm going to try to get my sprite to draw a square that literally goes around the shape of this square where you can see the grid lines right here. So I'm going to use 100 steps as my value for the steps. And again, we would have the students talk about, okay, well, the first side of the square, you would move 100 steps. And then what do you do next? Well, then at that point, you need to turn. So we grab a turn block, again, from the motion. We need to switch the value from a default of 15 degrees. In the Scratch environment, it's always defaulted to 15 degrees, so we would change that to 90 because squares have 90-degree angles. So right now, if I just break that apart for a second, I have one side length and what turn. So sometimes the conversation in the classroom will be, well, what next? Well, you need to move another 100 steps. So now we're starting to build the second side length and grab another 90-degree turn. And so that's two side lengths. And the students might say, well, we need to do that 2 more times. I'm just going to show you a bit of a shortcut here. If you right-click on the coding blocks, it'll give you a duplicate option. So this is just a quick way so that you don't have to continuously drag and drop. So students might be building their code to look something like this. Move 100 steps, turn 90 degrees, move 100, turn 90, move 100, turn 90, move 100, turn 90. All of these coding blocks will build the 4 sides of the square with the 4 angles. And that code will work. But what we are looking for, especially at the grade 6 level when we start talking about efficient code, is we might have a student say, well, can't we just use a repeat block? And that's what we are looking for. So under the orange control blocks, we have the ability to use a repeat loop. So what we ultimately want the students to connect to is instead of using all of these different blocks of code, which again will work, but the idea with coding is to code in the most efficient way possible. We want to use the fewest number of steps that we possibly can in our program. So instead of using 1, 2, 3, 4, 5, 6, 7, 8 coding blocks for this, we can take these 6 away because the core of this movement is the move 100 steps and turn 90 degrees. I don't need these, so I can just drag them over here to the side and drop them, which is basically a delete function. I can take my move and my turn and put it inside a repeat loop. And we would want the students to understand that they can't leave the repeats at 10. And the reason why is that a square has 4 sides, so these steps are going to repeat 4 times. So now we have a repeat of 4. And I click the green flag right now, and my cat, again, the object of this activity is to have the cat draw a square. So I click the green flag, and it is an incredibly quick movement that it looks like it's showing the cat moving in the shape of a square. And I'm showing this in this video because this is what is going to happen in the classroom when the students do this. They will see this and say, well, we need to find a way to slow it down so you can actually see what the cat's doing. And the learning we'd like to draw out with coding is that the under control, the very first function under control is called wait 1 second. And we want the students to understand that by putting a wait block inside the repeat loop, it allows the program to function a lot more efficiently, a lot less glitching, and the wait block will allow it to run without any bugs in the system. I'm going to put 1/10 of a second here, so very little wait time, 0.1 seconds. And now I'm going to click the green flag again. Still fairly quick. I'm going to change that to half a second. So 0.5, so we can get some talking about decimal equivalencies when we use the wait block, so 0.5 seconds. And now you can see the difference in the movement. By using the wait block, it slows it down just enough where I can truly see what's happening. So I have the cat moving in the shape of a square. But what I'm looking for is I want this cat, the sprite, to draw a square. So this is where it's likely going to be new learning for the students. There is nothing in here right now that will allow the cat to draw a square, but in the lower left-hand corner of the screen, there's this little blue icon that is the Add Extensions icon. So if I click on this, that will open up a number of different options that I have to add to my Scratch program, some different extensions, one of which is the pen. So if I click the pen tool, I now have all of these pen options that I could add to my program. So we need to literally program our sprite to put the pen down. Otherwise, it's not going to be able to draw a square. So I'm going to insert the pen down somewhere at the top of my code, just above my repeat loop. And now when I click the green flag, my cat has drawn a square. So that's the first part of the task that is now finished. Just a hint, one of the things that we show students as well is that if you are going to use the pen tool, it's always a good idea to grab the erase all block and use that at the very start. Put that underneath the green flag, and you will see as this activity starts to build why that might be important. So right now I have the first step of my code completed. I have a square drawn from the center, 0, 0 coordinates. The next step is I now need to start completing my overlapping continuous multicolored circle of squares. And the goal is to have this circle of squares go around and rotate exactly 360 degrees. So this is something where at this point, I would give the students a few minutes on their own to try to figure this out and determine, okay, what do I need to do with my code next to be able to figure this out? Some might get it quickly, some might really struggle with this. You might need to draw this on a board to illustrate this, but what we ultimately are going to want the students to connect to is that once that first square is drawn on the stage here, the very next thing that the sprite needs to do is slightly turn to be able to create that overlap. So we go back to our motion block and we want the students to understand that the turn block is what they need next. Now, as far as how many degrees they want to turn, that's going to be up to them. For me, I'm just going to turn 10 degrees. So after I draw my first square, my sprite is going to turn 10 degrees. You can see that my sprite is slightly angled now at a 10-degree angle. Now I want it to draw another square to be able to overlap that first square. And I want it to continue to do that. The connection we want the students to make is that they've already repeated their steps for their first square. Now they need to continue drawing multiple squares. So again, instead of the students continuing to duplicate this amount of work and doing something that's going to look like this and say, we are going to draw one square, turn 10 degrees, and then draw another square, and then so on. That code would get significantly long after a while. And you can see already that my sprite has now drawn 2 overlapping squares. So the idea will be to continue to repeat this pattern and rotating squares until it goes all the way. So what we want the students to realize next is, well, instead of repeating these same steps over and over again, what if we just grabbed another repeat loop and looped it around all of my other repeats? So this repeat of 4 right here that I'm kind of hovering on, that's my first square. I'm going to continue to repeat that square over and over again. How many times? Well, that's something that we need to determine. By default, the repeats are set at 10. Let's just take a look and run the program right now to see what this would look like. And the students will catch on that if they adjust their wait time, if they want it to run a little bit quicker, then they would just make a shorter wait time. So you can see right now, by repeating my square 10 times, I did not go all the way around in a full 360-degree rotation. And I'm not sure that I would necessarily use 360 degrees in my vocabulary as I'm describing this. I would want the students to try to make that connection initially, but we would want that learning to come out at some point throughout the lesson. So 10 repeats is not enough. So some students might be able to mathematically figure this out. Others are going to use trial and error. So if 10 repeats isn't enough, maybe 20 is. So I go around and I start running my program, and you can see it's going round and round, and hopefully this will result in a full continuous circle of squares. And it did not. So it's getting there, but it still isn't quite finished. So just to move ahead, and this is where a lot of the key learning is going to come in. It's one thing to be able to put the coding blocks together, but the other part of the mathematical understanding is we want the students to realize that if I need to go around in a complete circle, they need to connect that, well, a circle has 360 degrees of rotation. If I'm turning 10 degrees each time, each rotation, how many different groups of 10 do I need to turn to be able to get to 36? So that whole mathematical understanding of 360 being the multiple and then being able to connect, well, which factors would make a multiple of 360? And again, long story short, the answer would be 36. So if I repeat this process 36 times, 36 repeats times 10 degrees of rotation each time, 36 times 10 will give me 360. So we want the students by the end of this to understand that their repeats multiplied by their turns, their degrees of rotation, should equal 360 for this particular task, which is a circle of squares. So now if I run the program, we'll just kind of run that through to see, and this should be exactly one full circle of squares. Again, if you wanted to run this quicker, you could just reduce the wait time even more. And there you have it, a continuous circle of squares that is exactly 360 degrees of rotation. Now, the other part of this activity, though, which is basically a bonus component of the activity, is how do you make the colors change? So again, if we switch down to the pen tool, we would want the students to understand that by looking at the pen options, if they grab the option that says change pen color by 10, and if they put that in their repeat loop, so again, this first set of repeats is the square, the initial square that we drew. And then each time we draw a square, we're turning 10 degrees and we're changing the pen color. How many times are we making those changes? We're doing it 36 times. So I'm just going to reduce my wait time to 0 seconds, basically eliminate the wait time. Now I have my pen color. Now I run the program, and you can see that it's moving much quicker because of the reduced wait time. The pen color is changing, and this is a continuous multicolored circle of squares. That brings us to the end of step 2. Step 3, the next part of this process would be translate or move your sprite to quadrant number 1. So again, now we're starting to talk about quadrants. So quadrant number 1, a quick conversation showing the students that that would be this area right here that I'm hovering on. How can we translate and move our sprite to this area here? Actually, I'm incorrect. Let me back up just 1 second because there was another piece of code that I wanted to talk about first before we get to that. Step 3 is actually adding a conditional statement, which is our grade 5 curriculum. So if I add that conditional statement right now, let me just go to events, I'll grab a green flag, and now I move to control, and I'm going to grab a forever loop and an if-then statement. So one of the challenges that we were thinking about for this activity is, what if we made it so that if this sprite ever touches the edge of the screen, it stops the program, which is going to force the students to make adjustments to the code to be able to make this fit. So what that can look like is I'm putting an if-then statement inside a forever loop. And once I do that, the if-then statement inside the forever loop, this becomes a nested event. My repeat loop over here inside another repeat loop is also a nested event. Those are grade 4 curricular examples. My if-then statement, which means if a certain, if something happens, then another condition is going to be met. So if touching edge, what I wanted to say is if this sprite is touching the edge of the screen. So I go to my blue sensing block, and the very first option says touching mouse pointer. I'm going to switch that by clicking the drop down and change it from mouse pointer to edge. I'm going to put this in my if-then statement. If touching edge, then under the orange control block, we want to show the students that there is a stop all option. So this is a conditional statement, which is my grade 5 curriculum, inside a forever loop, which is now a nested event, which is grade 4 curriculum. And I am trying to do this in the fewest number of steps possible, which makes it efficient code, which is the grade 6 curriculum. Now if I click the green flag, you can see that my sprite has hit the edge of the screen and it has stopped my program. So the challenge to the students would be, well, what do we need to change in the program to fix this so that it does not stop, so that it will continue? So I just wanted to show you that quickly. Now the other next step, let me just break that code apart and run this again. As this program is running, now we challenge the students to move their sprite, translate this pattern into quadrant 1, and now be able to do the same thing. So ultimately we would have the cat move over here somewhere in quadrant 1, and instead of this circle of squares moving around in the center of the screen, how do we have it move up here in one quadrant? And in order to do that, we want the students to experiment, and we want them to understand that, again, the sprite moving to a different area is controlled by the XY value. So if I want it to move over here where I'm hovering right now, that would be coordinate 100 in the X value and also 100 in the Y value. I could try that. So let me change that code. 100, and then I go to Y, 100. So now if I try that same pattern, I am now drawing my circle of squares that is mostly within quadrant 1. So you can see how by adjusting my X and Y value, I've now translated that pattern to a different area on the screen. What I would challenge the students to do is how can we adjust our code so that this circle of squares fits entirely in quadrant 1 without any overlaps. So again, the students would need to take a look at their code, and there's a few different options that they could use. They might decide to take fewer steps. So for example, instead of 100 steps, if I reduce that to 50 steps, now I run my code, and I have my sprite now doing a continuous circle of squares that's entirely staying within quadrant 1. So again, just a few different ways that we can incorporate efficient code in the fewest number of steps possible with conditional statements, which would be grade 5, and also building nested events, which ties in our grade 4 curriculum. I hope this video has been helpful.